The study of kinetics, or rate of reaction, involves some repetition of GCSE work, and AS in Year 12 introduces the Maxwell-Boltzmann distribution, and then the study is revisited in Year 13 on a slightly more mathematical approach. So the first few slides are just going to look at the specification, and clearly now you know they are there here at the beginning of this first presentation. Then do refer back to them. So clearly you need to pause the video, read through this in your own time. Collision theory is something that was introduced to at GCSE. And we move on to the next parts. The Maxwell-Boltzmann distribution is new. And factors which affect rate of reaction include temperature, which is here, and as you note it is a required practical. Other factors include concentration, pressure, catalysts, it's really important to understand that in this topic, rates of reaction or kinetics, all the information that we deal with is obtained from experimental results. This experiment here is one you've probably investigated at GCSE. So we are looking at the reaction between calcium carbonate, which is marble chips, and dilute hydrochloric acid. And at the bottom, the last sentence says we are going to change the concentration of hydrochloric acid. So what I want you to think about is what variables will be present in this reaction. So if you pause the video, make a list, and then we'll start the video when you've completed your list. Hopefully the variables that affect this reaction concern the chemicals. So we have calcium carbonate. So to make it a fair test, we would need to keep the mass of calcium carbonate the same, the surface area, and the hydrochloric acid. At GCSE, it is incorrect, and at A level, it's incorrect to use the word amount. We need to be specific. So for the hydrochloric acid, we need to talk about the concentration of the hydrochloric acid and the volume. We don't need to talk about apparatus. We don't need to talk about things like keeping the conical flask the same. But the one other factor would be the temperature. And again, we need to be specific, because temperature could refer to the room temperature. But we really mean the temperature of the hydrochloric acid. So I hope you've got all those variables. So whenever we carry out an investigation, we can only change one of these variables. And I hope you remember that this question was concerned with investigating the effect of the concentration of hydrochloric acid on the rate of reaction. The variable that we change is known as the independent variable. So in this case it's concentration. And the rest are all known as control variables, and we need to keep those constant. So let's now consider the quantities we could use. So let's start with the calcium carbonate. We will use 1 gram of calcium carbonate. Keep this constant in every experiment we do. We want excess hydrochloric acid. So my question is, what volume of carbon dioxide will be produced from 1 gram of calcium carbonate? So pause the video and complete the calculation. We first need an equation. Calcium carbonate reacts with hydrochloric acid to give us calcium chloride, water and CO2. And as you can see, if we start with 1 mole of calcium carbonate, we produce 1 mole of carbon dioxide. So the number of moles of calcium carbonate is the mass over the MR, and that is 140 plus 12 plus 3 times 16, which equals 1 over 100. Now for a gas, 1 mole of any gas has a volume of 22.4 decimeter cubed at standard temperature and pressure, which is 0 degrees centigrade, or 1 mole has a volume of 24 litres at room temperature and pressure, room temperature being approximately 25 degrees centigrade. So in this case, the number of moles of carbon dioxide is 1/100th, and therefore the volume of carbon dioxide would be number of moles times volume of 1 mole, which is 24 litres, is 1/100th of a mole times 24 dm cubed, which is 24,000 cubic centimetres, 240 cubic centimetres. As you'll remember from your previous topic, it's really important that you set your calculations out clearly and you state what you're calculating. So my first step here, I'm calculating N. N is the number of moles of calcium carbonate, and then further down the page I'm calculating the volume of carbon dioxide. In the previous slide we considered all the variables that will affect this reaction, and the variable we were going to change, the independent variable, was the concentration of hydrochloric acid. And as you can see at the top of this slide here, the hydrochloric acid is in excess, and so even though we're going to change the hydrochloric acid, we will always have an excess. Therefore, in every experiment we start with 1 gram of calcium carbonate, we will only ever produce 240 cubic centimetres of carbon dioxide. So as far as rates of reaction is concerned, we've got to be really careful what we measure as our dependent variable. The dependent variable wouldn't be volume, because in every case the volume would be the same. It's really important for you to appreciate that when we carry out one experiment, it's not the total volume of gas that we're going to collect. In this case it'll be 240 cubic centimetres in every case. So it's not the volume, but it's the rate at which the gas is produced. And rate is a function of quantity of a chemical, so in this case it could be the volume, it could be the mass, divided by time. So our dependent variable will be the rate of reaction, which for this experiment might be the volume divided by the time, or the mass divided by the time. In the next slide we're going to feature a second very simple reaction, and this time it's a reaction between magnesium and hydrochloric acid. And as it says at the bottom, the student is going to investigate how the temperature affects the rate of reaction. So can you pause the presentation and make a list of the variables that affect this reaction? So let's consider the chemicals involved. We have hydrochloric acid, and as far as hydrochloric acid is concerned, we would need to consider its concentration, the volume, and the temperature. And for the magnesium, we'll consider the mass that we use, and once again its surface area. Now of course, if we use a piece of magnesium from the same length, from the same coil, then the surface area will be the same. And the investigation suggested it was going to investigate the effect of temperature. So in this case, temperature will be our independent variable, and we would need to keep all the other variables constant to make it a fair test, and our dependent variable would need to be the rate of reaction. We're now going to look at a different reaction, which again you may have also studied at GCSE. And this reaction goes under the name of the disappearing cross. And if you look at the picture in the bottom right, that is because there is a cross drawn on a piece of paper, and when the student looks through the conical flask, through the solution, the cross appears to disappear. Of course, the cross is still there, it's just no longer visible. So if again we consider the variables in this reaction, the two chemicals are solutions of sodium thiosulfate and hydrochloric acid. So can you pause the video and make a list of the variables? So the sodium thiosulfate has the formula Na2S2O3, and because it's a solution, then we need to consider the concentration and the volume. And for the hydrochloric acid, again, the concentration, volume. Now temperature is another factor we need to consider, and what we really want to do is take the temperature of the mixture of sodium thiosulfate and hydrochloric acid at the start of the reaction, take the temperature at the end of the reaction, and then if we have an average temperature, that would be the value that we would record. And you may recall from the previous slide that this investigation concerned changing the concentration of the thiosulfate and investigating the rate of reaction. So all the other variables would be constant. We're going to change the concentration of sodium thiosulfate as our independent variable and measure the rate of reaction. That would be our dependent variable. So I want you to pause the video now and think about how we could record the rates of reaction for this reaction. In this reaction, we start with two solutions. No gas is produced, but sulfur appears as a precipitate. So it's the mass of sulfur in a period of time that we want to record. And that is how we would consider the rate. It is the mass of sulfur, solid, over time. And I want you to think of the practical implications of how you collect and record. So pause the video and I want you to think about how you could determine and record the mass of sulfur. Well, I hope you appreciate that the answer is this is not practical at all. The sulfur would have to be filtered from the reaction mixture. We would then need to dry it, record the mass, and therefore go back and consider the mass that had been recorded in the period of time when we stopped the reaction. So that's not at all practical. But what we do is we make the assumption that the mass of sulfur required to obscure the cross is the same every time. And that mass therefore can become a constant. And so the rate of reaction would be not equal to 1 over time, but proportional to 1 over time. It doesn't equal 1 over time because in the top equation we need a mass of solid that we divide by time to give us the rate. But since we assume that the mass of solid is the same to obscure the cross on each occasion, then we can make the assumption that the rate is proportional to 1 over time. So on the next two slides there are two videos which are GCSE required practicals. So I want you to move on to each of these videos, watch each and make sure you're completely happy with both of these practicals. So having introduced the topic rates of reaction or kinetics and emphasised how important the practical work is, because we use the practicals to obtain the results, we are now going to use these results to work out rate of reaction, and that is on the next video. So I hope you've enjoyed this so far and move on to the next one.